We're going to start at your EC2 console. We're going to scroll down over here to Load Balancing and select Load Balancers. Click on Create Load Balancer. We will be creating an application load balancer. Let's just name this Demo. And don't worry about most of these settings right now. We're not going to be adding any more listeners, but if you're running a secure site, sending or receiving any sort of information you wouldn't want made public, you'll need to set up HTTPS. We're not worried about that right now, so let's go ahead and scroll down to availability zones, and since we want our server to be nice and available, let's go ahead and select all of these.
Now for this demo, we aren't going to worry about the security setting for this server because we're not going to leave it running. We'll be focusing on security in a later tutorial. Right now, we're going to keep things simple as this is just a demonstration. Let's go on to the security groups.
Let's go ahead and create a new security group for this. Now, you may already have an existing security group. We're going to create a new one. Let's just call it Demo Group. Alright, now we've got port 80 open for HTTP, but we also need to open up port 22 for SSH. Now, we're going to go ahead and restrict this to our IP address. It'll add a little bit more security and is usually a good idea. Again, this is just a demonstration and this is not a secure server at all, so don't set this thing up and leave it running. Again, we'll be locking things down in a later tutorial, but it's useful to understand right now how this works. So let's go ahead and configure routing.
Okay, we're going to create a new target group. And let's just name our group Demo. Target type is instance. We're going to leave our protocol and port the same. Under health checks and under path, we're going to type in index.html.
This is the web page that we're going to create, and it will be what AWS uses to make sure our website is still healthy and up and running. Now, we don't need to change anything under advanced health checks for now. Let's go on to register targets. We don't have anything to register right now, but that's okay. We're going to add it later. All right, let's go ahead and review these settings. That all looks fine. Let's go ahead and click on Create and Close. And it'll take it just a few minutes to provision everything.
Okay, now that we wait while our load balancer is provisioning, we can go ahead and create our launch configurations. From your EC2 console, select Launch Configurations. And we'll tell it that we need to create a launch configuration. Let's go to Amazon Linux 2.
Now, when you're asked about the instance type, you'll notice there's only one with this little green box. It says it's free tier eligible, so obviously that's the one that we're going to use. Don't worry, this is more than enough for a simple small site that doesn't get a whole bunch of traffic, and it'll work great for our tutorial. Again, we're not going to leave it running. Let's go ahead and go on to the details.
And we're going to give this configuration a name. Let's say Demo Server. We're not going to worry about spot instances right now. For the purpose of this tutorial, it's not something we need to deal with. Same for IAM roles or CloudWatch monitoring.
However, we are going to need to come down here and select Advanced Details. We want to add our Bootstrap script into the User Data section. We're going to paste the following script into this box. I'll copy it from my text file here. And paste it in the box. And all this is going to do is run some simple updates, install our server, start it up, and it will create a very, very amusingly simplistic web page for us.
All right, let's go to storage. We're going to leave it as default. It's more than enough for this tutorial. Let's go on to configure security groups. Now remember, we've already created our security group, so all you have to do is click on existing security groups and click on our demo group.
Alright, let's review this. This all looks pretty good. We can go ahead and click on Create Launch Configuration. Now, we've already got an existing key pair here. Of course, you have the option of creating a new one. Again, we'll just click on Create Launch Configuration.
Now we're going to go ahead and select Create an Auto-Scaling Group using this launch configuration.
We'll just name our group Demo. Let's go ahead and start with, let's say, 2 instances. That's pretty good. We'll keep our default VPC, and under Subnet, as soon as we click on it, it offers us some options. We want to go ahead and select all of these.
Under Advanced Details, go ahead and select Retrieve Traffic from one or more load balancer. Under Target Groups, go ahead and select our demo group. Let's set this health check grace period at 60 seconds instead of 300. This is how frequently our instances will be checked. If one or more has failed, another instance will be spun up in its place. We're going to just set it at 60 seconds because it will make it a little easier to demonstrate how it works. Let's leave everything else at the default setting and go to Configure Scaling Policies.
Alright, we just want to keep this group at its initial size of 2 instances. That's fine for us. Let's go on to Configure Notifications. And now, we're not going to worry about this right now because this is just a sample for the tutorial. Of course, if you wanted to be notified about changes or issues with the server, if one of your instances fails, this is where we would set it up. For a small static site, for a demonstration, this isn't going to be an issue. So let's go ahead and go on to Configure Tags. We'll give this a name, call it Demo, and let's go to Review. This all looks good. Let's click on Create Auto-Scaling Group.
Let's close this and we're going to be taken back to our auto-scaling group page. Now if I go back to my instance page, I can now see that 2 instances have been created and are spinning up. Okay, it's been a few minutes and our instances are up and running. Everything looks good. And if I go and copy the address of our load balancer and toss it into a new tab, you can see our website.
Now, of course, this is a ridiculously simple site. Of course, you'd obviously want to do a lot more for anything more than a simple demonstration HTML file, but for today's tutorial, that'll do. Our sample site is now up and running across 2 instances. You can check the auto-scaling group to ensure it's working by terminating one or more of the other instances. So if I pull up my instances page, and let's say I terminate one of these, now, since our group calls for 2 to be running at all times, another one will be automatically created from our image in Bootstrap script and spun up to replace it. It will, of course, not be created until it's failed the health check that runs every 60 seconds, so we'll need to wait a few moments for this.
And there you go. The auto-scaling group realized we're a server short and has spun up another. Now, since this is just a silly demonstration site, and so this isn't particularly secure, we're going to go ahead and shut it down. We do this by first deleting the auto-scaling group. Then the load balancer. And finally, let's terminate our instances.
Alright guys, we're going to leave things here today. In our next video, we're going to have an identical 2-instance load-balanced auto-scaling web server set up, and we'll load test it with a tool called Locus and see how it holds up. Is it possible this site isn't quite as capable as we'd hoped? We'll find out next time.
It with increasing number of GET requests.
We're going to start by creating an Ubuntu instance. And you might be wondering, why Ubuntu? By default, Ubuntu instances have Python 3 installed rather than Python 2.7. Amazon Linux and Red Hat both use 2.7, and you'd have to install 3 over it because Locus requires Python 3. Running an Ubuntu instance can save you a lot of time and frustration. So we're going to stick with that.
To get started, just log into your AWS console and launch your instance.
Launch an instance here. We will be choosing Ubuntu Server right down here. Alright, now Locust's requirements are negligible. We can keep all of this in the free tier. We're just going to choose general purpose here.
Here we're going to keep all your configurations the same.
Don't need any significant storage. We can add a tag here. Let's just give it a name. Call it Locus. Now, for the purposes of this tutorial, we're just going to open this thing wide up. I'm not worried about any security. Obviously, your requirements may be different. It's up to you, but just for today, we're going to keep this thing open. All right, let's check it out.
Everything looks good, and we're ready to launch.
All right, we've already got an existing key pair here. We're just going to use that. You can use your own, of course, or create a new one. It's up to you.
And we're going to pause here and let our instance spin up.
A few moments later.
Alrighty, our Ubuntu instance is up and running. We're going to SSH into it. Our key file is already in our home directory. We haven't set up our SSH config for this server. We're not planning on leaving it up anyway. But if you're going to be doing this often or leaving it running, that's something you'd want to do. Let's see, we're just going to connect. I can copy this exact command here. Pull up my terminal, paste it in, and we are on.
Alright, now what you need to do is a quick maintenance task with your new instance. So let's run sudo apt update. Alright, after that, now after that, do a sudo apt upgrade.
Thousand years later.
Alright, now we just need to verify that we do in fact have Python 3 installed. So let's do a quick version check by typing python 3 -- version.
Alright, and we've got Python 369 installed. Now, for the Locus install, we also need pip installed, and that is not installed by default. You can give that a check. And it'll tell you it's not installed, but how to install it. So we're just going to do that real quick. Sudo apt install python 3 pip.
Thousand years later.
And we are ready for our Locus install.
This is also quite easy. Type in sudo pip3 install locus and let's run it.
One eternity later.
Alrighty, now it's installed, but if I try to call it up, it's just going to throw an error message at me. I'm going to lazily correct this by rebooting the instance real quick. Sudo reboot now. I'm going to give it just a minute, and then we are going to SSH right back in there.
Alright, our instance has rebooted. We've SSH'd into it, cleared the screen, and now we're ready to go.
We can now run Locus, but it immediately throws an error message at us because it doesn't have a script yet. We need to give it one.
We provide our sample script in the link below.
Now, we've already got the script file in our home directory on our local machine, so let's use the rsync command to put it up on our instance. I'll just pull up a local terminal window and issue the following command. Now, this looks like a doozy of a command, but it's not really that bad. We issue the rsync command, give it write permission, tell it we're syncing via SSH, include our key file. We're telling it the file name, giving it our instance address, and telling it where on the instance we're going to put it and the name. Since we're keeping all of these in our home directory, we don't need to specify any paths. But if this wasn't in your home directory, or if you wanted to put it somewhere other than your home directory, you would need to tell it exactly where these files are, otherwise this command wouldn't work.
Please keep in mind that this is a very basic script for the purpose of our demo. Locus is well documented, and we would absolutely encourage you to read more about it on their site. You could do all sorts of cool stuff with it.
Alright, it looks like the file has been synced. I can check with a quick ls command. Looks like it's up there. Now, if we wanted to pull up Nano, we could check out our script, make any edits that were needed, anything else like that. Ours is a very simple script. It hits our load balancer with repeated GET requests with however many simulated users we'd like to create. You would of course need to replace this address with whatever server you're testing. This all looks fine, so let's just exit out of here.
Now we can just call up Locus, and we can get a quick confirmation that things are running. Alright, let's open a tab and head over to our instance IP on port 8089. Alright, so we got our UI running, nice and clean. And as you can see, of course, this is pretty simple to understand. You can input a number of users, let's say 2,000. And then you can also choose how quickly to produce those users, let's say 50 per second. Put in our load balancer address. Right here. And start swarming.
Alright, and you can see our number of simulated users rising. We can see the number of requests per second these users are making. Looks pretty good so far.
No failures yet. There's one.
Starting to look pretty awful, in fact. We haven't even hit our full 2,000 users yet. Already seeing 10% failure rates. Let's let it get up to 2,000 and see what we've got. Yeah, let's go ahead and stop this. And let's head over to our charts, and we can see exactly what we're doing wrong here. This is going to be running a cleanup for a little while. We're just going to check our reports. If we look at our charts tab, we can see the moment that we started to get right around 500 requests per second, and our site started choking, and it continued to get worse. If we'd simulated 3,000 or 4,000 users, we'd likely see far worse. Response times were just disgraceful. Yeah, this would not fly.
We can see specific errors, of course, since our script merely hits the server with a GET command. Those are the only errors we're going to see. You can also download the data in CSV form if you need.
Now, you might be wondering, why would I want to do this? Wouldn't alarms be blaring on my AWS console? Well, the reason we do this kind of real-world simulation is precisely because the AWS alert metrics are relatively limited. Let's look back at our console. Don't see anything wrong with my load balancer. If I look at my EC2 dashboard, all these are running. These are my auto scaling group that are running under my load balancer, and they're all checking out. Things look okay. Instance reachability checked passed. This all looks good. We had an auto-scaling group designed to trigger in the event of CPU usage spikes, but they haven't been triggered. Our client might be experiencing site failures left and right, and we would have no idea anything was wrong. If this was a real site, we would have some work to do.
So guys, this was a very basic tutorial for spinning up an instance, installing Locust, and running a script against the site. You'd obviously want to customize each of these steps for your specific needs. And if we're doing this regularly in a professional setting, we just set up a script and do it all for us because we hate doing things twice.
Now, it's very likely that we've done something stupid at some point in this tutorial, and that's fine. We're all learning, and making stupid mistakes is part of the process. Hopefully, this has been helpful to you. If you have any questions or comments, please feel free to reach out to us. Thank you.